Good morning, everyone. Hope you all are having a good day today. Trying to think if there's any announcements. Keep working on the project. Yeah, don't forget about it. So today's all about Chapter 11, which is the Data Analytics chapter. So specifically, we'll start off with a good introduction of what data analytics is. Then we'll cover data warehousing. We'll talk a little bit about online analytic processing. We'll cover data analysis. And lastly, how we actually would use a SQL database to do analytics, which is probably the most important topic of the class. Is that fair to say? At least of today's class. So, if you think back to a couple weeks ago, okay, we did queries, right? You guys remember I gave you 18 tasks? That's basically what you need to know for SQL. Okay, if you know how to do that stuff, it means you know how to do pretty much anything you would reasonably need to do inside of SQL. However, you're not always going to be in SQL, are you? Okay, so we're going to talk today about actually integrating SQL with other stuff, which I think is a pretty cool and important topic. Before we do, though, let's talk about the business analytic process. So each company has a unique process that they may use to sort of ensure that they're collecting all the data that they need, and more importantly, that they're interpreting the data and performing analysis on the data. And an organization has different needs. So someone throw me your favorite company. I'm sorry? Favorite company I know something about. Okay, Amazon. Okay, Amazon has vastly different needs than any other company. Okay, so Amazon is comprised of Amazon Web Services. Okay, they're comprised, of course, of Amazon, the storefront. All right, virtual retailer, e-commerce. All right, they may have a multitude of different applications that they need because think about it. They're the biggest provider, at least of United States companies, of cloud services. Okay, when AWS goes down, you know, half the internet's down. Is that kind of crazy? Okay. So someone throw me another company. Okay. I don't know anything about Red either, though. Company I know something about. Okay, Google. So Google has how many different divisions? Okay, hundreds, right? I couldn't name them. I mean, off the top of my head, they have, you know, obviously search, it's kind of their thing. Probably have a Gmail division, a Maps division. Waze would probably be separate from Maps, although less and less. What other divisions? I mean, they have Android, of course, so they have probably teams within Android. Yeah, YouTube, that's a big one. I use YouTube pretty regularly. I think you all know that. Yeah, a lot of different divisions. Each of those divisions may have their own needs. Okay, so the idea here, though, is that anything we're doing, we want to make sure that it is going to be organization-wide. Okay, and we're going to talk about enterprise data warehouses in a couple slides here. But the idea is that we have a shared collection of databases that are basically going to be, I don't want to use the term combined into one database, but we're going to be able to gather information in a central repository. Okay, and the idea behind this is that we can then go out and as a company, okay, we can actually then formulate analytics based on the central data that we all share through the data warehouse. And that's going to help us support organizational transformation. So what that really means is that we're going to be able to sort of base a lot of our decisions on analytics. Okay, why is that beneficial? Okay, you've taken 223. Why do we do analytics? Yeah, so, you know, I think personally, in my opinion, I think behavioral research is bogus. All right? You ask someone what they want to do, you know, there's roughly a 50% correlation with what you want to do and what you do. Okay? So why would I care about intention? Analytics, however, are actual behavior. Okay, if we're let's go back to Amazon. And let's specifically think about their e-commerce site. Okay, so if we're Amazon, we have customers. We know what they actually purchased, do we not? Okay, we know what they returned, do we not? So I have a product that has a 50% return rate. Should we do something about it? What should we do? Well, we probably don't make the product to fix it. It's just a retailer most of the time. Even Amazon Basics, they don't technically make it. Well, why would we promote a different retailer? I think what you mean is a different product. Because, you know, Amazon is the retailer. They wouldn't promote their competition. But they would promote other products, and they could even drop a bad product. Let's face it. Returns are not cheap. Okay? What costs do we face with return? Okay, shipping, that's the big one. What else? So, could be some additional storage component. I could certainly see that. Yeah, definitely labor is going to be a component. What about just straight up lost merchandise? Okay, that's going to be factored into stuff like shrinkage. Okay, now a lot of times, of course, that will not be a cost that Amazon directly eats. Okay, because there are going to be third parties on Amazon who may be selling the products or services. We don't really know. All right, but keep that in mind. The idea here is that this is going to allow us to really support a lot of organizational transformation. That's the goal. Okay, because if we're a static company, let's say we are Blockbuster. You guys familiar with Blockbuster? Why did I bring that up as an example? As a static company. So they declined to purchase Netflix, right? Okay. Was that a wise move? Looking back, it was not. Okay, at the time, Blockbuster was doing very well. All right, there was a point in time in which you couldn't not go to a Blockbuster. All right, who misses those days? Okay, we've got a Blockbuster fan. You're from Alaska, right? You been to the Blockbuster up there? Is it still there? I think there's still one somewhere, but anyway, you know, it's a very static company. They made decisions not based on future, they made it based on the present. Okay? Is that wise? Think about how many massive retailers have gone under in the past 10 years. You know, I mean, Sears has certainly declined, Kmart's certainly declined, JCPenney's certainly declined. There's a bunch of other sort of regional ones that had hundreds of locations that no longer exist. They didn't transform to meet the modern business. So let's talk about the stages of analytics. All right, it's pretty important that you write this down, okay, because unless you want to read Davenport's 2010 Analytics at Work book, all right, you can probably check out the library if you're interested. But this is pretty much the big takeaway from the entire book, so, you know, make of that what you will. So companies without any analytics at all are what we consider analytically impaired. Okay, it means they don't have the ability and they're not using any amount of analytics. Okay, after that, we have localized analytics. Localized analytics are when one functional unit within inside of an organization is using analytics. Okay, so for instance, let's say we had Walmart. And Walmart may have a product selection team. I don't know what it's called. I don't work at Walmart, okay? But that product selection team may use localized analytics. All right? And they're using analytics, but the rest of the company would not be in that example, okay? Analytical aspirations are when the company begins to want to move toward having analytics across the organization. Okay, and specifically, this is where you get top management buy-in. Okay, so typically C-level, possibly director. If you don't have top-level buy-in, can you do anything? No. All right, I'm just being blunt. All right, if you don't get top-level support for something, you might as well give up. Okay, or better yet, you should probably try to get top-level support. Is that an easy thing to do? You have a 100,000 employee company. You think you can just get a meeting with a CEO? No. How do you do it? You got to go up the chain, exactly right. Okay? Is that frustrating? I think it probably would be. All right? But guess what? It's reality. All right? Analytical companies are going to be, we've deployed analytics throughout the company. And finally, analytical competitors, not only have we deployed it, not only are we actively using it, but we're basing all of our competitive decisions on analytics. Okay, well, I wouldn't say all, but most. So if I am, let's say I'm Newegg, okay? I want to decide how to price my products. Okay, I'm going to use analytics to do that. Because, in this example, they're an analytical competitor. All right, questions about these? Make sense? I'm confused? So, anything in business, particularly anything where it's something that can be used to generate revenue. Okay, you always want to start with your company's strategy. Who can tell me the two strategies that Michael Porter identified? Cost leadership is one. What's the other? Differentiation. Glad to hear you all know that. Which class is that in here? Is it management or strategic management? Y'all taking that this semester? It's an important class, okay? Always consider the strategy of your company. So let's say we're a cost leadership company. What should our analytics be focused on? Operational efficiencies, exactly right. Okay, because we want to be able to offer products and services for the lowest price possible. So Walmart, their motto, I don't know if it still is, save money, live better. Okay? What does that mean? Save money and live better. Does it mean improve your standard of living and spend less? That's exactly what it means. Okay, what do y'all think of that? What's your opinion of it? Okay? Saving money, living better. Sounds pretty good. You wouldn't want a motto like spend more, live worse. Maybe I should start a business like that. I could probably get some of these. Never mind. Anyway, back to the topic. Okay? So consider the data that you have. And, you know, it's important to think about this from a database perspective because you have to understand you don't have a single system as a company. Very few companies are going to have one system. Okay, even an ERP is really a combination of systems, is it not? So what you're doing when you're managing the data in the context of business analytics is you're really sort of gathering the data into a usable format for analytics. Okay, and that's going to be something we're going to talk about in a couple slides. But the idea is that it has to be easily used, and it also has to be time variant. Why is time variant important? Well, so time variant means that it has a date and time variable in it. Why do we need that? Okay, because we want to know historically what has happened. We want to know how are we trending. We cannot do that if we don't have the date and time. Is that fair to say? I think that's pretty fair to say. All right, so that's managing data, collecting it, having policies associated with it. We've talked about data governance in here, right? I think so. Anyway, what's data governance? What is data governance? It's a good definition. So it's really all about what we collect, why we collect it, how we collect it, how we use it. That's all data governance. That's all managing data. All right, then, it doesn't do a whole lot of good to just have data. If I had data and did nothing with it, what's the point? Just collecting it for fun. For my records. How about that? So we have to analyze it. Three major types of analysis. Okay, we're going to talk about these in the subsequent slides. We have descriptive, predictive, and prescriptive. Okay, and then finally, once you have prescriptive, suggest an action, you take the action. Okay, because you can run through all the analysis in the world, and if your manager just shreds it, it doesn't do you any good. You wasted your time. All right. So the first type of analysis is descriptive analytics. Okay, so what we're doing here is we're taking a data set and we're describing it. Okay, a lot of the times when you're talking about this, it's descriptive statistics: mean, median, mode, standard deviation, skew, kurtosis, all those sort of things. Okay, so really straightforward, just descriptive. You're not predicting anything with a mean. Okay, you're just describing a data set. All right. So if you think about this, what you're really doing is you're saying we have these characteristics inside of our data set. All right, is anyone confused so far? Okay, so one example of this is decision support systems. All right, what we're doing here is a lot of different things. Okay, number one, a decision support system does not tell you what to do. Okay, it's possible it may suggest a course of action, but most of the time, really what it's doing is it's giving you supporting evidence for making a decision. It's not making the decision. There are types of DSS that do, but in general, from a definitional standpoint, we don't consider that a DSS system is literally making decisions. Okay, so think about sensitivity analysis. Okay, so sensitivity analysis would do things like tell you how sensitive data would be to a change. Okay, so then you have what if analysis. What if is, of course, as the name would imply, telling you what will likely happen if some change is made. Okay, and then goal-seeking analysis. All right, so this could be something like you have a goal of retiring with $5 million. Okay, what do you need to get there? Okay, well, obviously you need to invest and you need to obviously get decent returns. All right, pretty straightforward stuff there. Could also be you want to earn an A in a class. All right, so probably some other class, maybe you're having a little bit of trouble in. Okay, let's see. I'm trying to think of which class you all would take that may be tough. Finance. That's not an easy class, is it? All right. Do goal-seeking analysis to see what grades you need to make to get an A. All right. Of course, we also have examples of data mining. Not all data mining, of course, is going to be descriptive. Some of it will, though. So, for instance, sentiment analysis. All right. Most commonly used on stuff like social media, right? All you're doing is you're describing the general sentiment within inside of the data. All right. Same thing with looking at historical patterns. That's stuff that's already happened. You're describing the data. You're not predicting anything. That's historical. Okay. Any questions? All right, predictive analytics. What's a prediction? Probably some sort of educated guess about a future event, right? All right. What we think will happen. So if we think that, what might we predict? If we think it's going to rain tomorrow, who thinks it might rain tomorrow? I didn't say where it might rain tomorrow. Probably will rain somewhere tomorrow. Is that fair to say? Anyway, okay. What might we do with that information? Might you wear a rain jacket? Might you bring an umbrella? Okay. What about rain boots? You might. I don't know. But some other types of data mining that may be relevant here with prediction, things like predicting a future trend. All right. So you have a data set. You're not just looking at the past trends, you're looking at what might happen in the future. Okay, looking at behaviors, making a prediction as to whether something is fraudulent or not. Making a prediction as to whether someone will default on a loan or not. That's data mining. Okay, because are we just asking the person, are you going to default on your loan? Is that how we do this? If Ben's applying for a mortgage from me, am I going to say, Ben, are you going to default? Okay. Do we trust Ben? Okay. We might trust Ben, but we might not trust other people. Okay. So you would, of course, build a model. Now, keep in mind, there's a lot of federal regulations. Okay, and we're not going to go too much into those, but obviously, we don't want to violate the Fair Housing Act. Is that fair to say? Okay. And I'll leave it to you what your opinion of that stuff is. I don't really care what your opinion is for that kind of stuff. But another example is regression. Okay? So regression, you have your predictors, and you have your DV. Okay? So really straightforward. I don't think we need to go too much into regression. Forecasting. Okay, we have lots of different types of forecasting. You got seasonal. Okay, you have stuff like simple exponential smoothing. Okay, you have Holt winters. You have just Holt. You have just winters. Okay, I can list forecasting all day, but I don't think that's what you all want to hear. All right, so some simple forecasts. You got naive, just literally looking at the previous period. Simple moving average, as the name would imply, you're taking an average. Okay, so if you wanted to get a 3/4 simple moving average, how are you going to calculate that? Okay, so and specifically, what you're going to do is you're going to take the 3 most recent quarters to whatever you're trying to predict. Is that right, Ron? That's exactly right. Okay, weighted moving average. Why might we do a weighted moving average? So exactly, so certain periods we may believe are more indicative of future performance. So for instance, say we're using quarterly data. Where's the marker? So we have quarter 1, quarter 2, quarter 3, quarter 4. I really did not plan that out very well with the different sizes, did I? Okay. We're trying to predict quarter 1 of the next year. We may place 0.5, that's 50%. Okay, we may place 0.2, 0.1, and in the most recent quarter, we may place let's make this 0.1, make this 0.3. All right, so what are we doing here? We're placing emphasis on the like quarter, 50%. We're placing emphasis on the most recent quarter, 30%. The other 2 jokers get 10%. All right, what do these have to add to? 1. Because when we multiply by these, we don't want to multiply by anything other than 1. Simple exponential smoothing. Again, we have some alpha constant. Alpha is between 0 and 1, including 0 and 1. Okay? What we're doing is we're taking alpha times x sub t minus 1. Okay, then we're taking 1 minus alpha. Whoops. Multiplying that by f sub t minus 1, the previous forecast. So previous observation, previous forecast. Does everyone understand it? Anyone confused? Okay, what type of forecast is this? Okay, so we talked about it. Which one of these is it? Simple exponential smoothing, exactly right. Where does alpha come from? Okay, so alpha is given. Okay, if you want to place more emphasis on the most recent observation, you'd have alpha be closer to 1. If you want to place less emphasis, you'd have alpha be closer to 0. But any value we put in alpha, as long as it satisfies these criteria, this plus this is going to add to what? 1. Exactly right. We make alpha 0. You got 0 plus 1 minus 0, that's 1. Make alpha 1. You got 1 plus 1 minus 1 is 1, right? What if we make alpha 0.3? Okay, you got 0.3. 1 minus 0.3 is 0.7, so 0.3 plus 0.7 is what? 1. Is that kind of cool? Is it cool at all? How much street cred does this have? Okay. It's almost too cool for school. Seasonality forecasting. So you have different periods. Maybe it's quarterly, maybe it's monthly, maybe it's even weekly, maybe daily. Daily's not really going to be that useful, but you could use it, okay? All you're doing is you're applying, or you're not really applying, you're first calculating up and seeing what your seasonal constants are. All right, that's pretty easy to do. And then you're taking those seasonal constants, you're multiplying it by whatever period you're within. And of course, you'd have some sort of trend that you would then apply that to. Okay, so speaking of trend is going to be a period between 1 and 3 years looking at growth or decline. All right. So any questions? All right, prescriptive analytics. So we predicted what's going to happen. Now we're prescribing something about it. All right, when you visit a physician and you have a problem, they prescribe you something, right? It's recommending an action. So think about driving. Okay, anyone drive in here? I'd assume you probably do. So when you learned how to drive, they probably taught you this: identify, predict, decide, and execute. All right? So what this means is when you're driving down the street, you're identifying your surroundings. Okay? How do you do that? You look out the windshield. Is that fair to say? Okay, so you're looking out the windshield. You're trying to see what's in the road. You're predicting what will happen. Okay, if you're in a neighborhood and you see a little kid playing basketball and they're in the road. Okay, is it fair to make a prediction that they may run out in front of your car? Okay, then you decide what to do about it. All right? Hopefully the decision is to avoid the little kid. All right? Hopefully. All right? You know, I'm not here to say, you know, that we should support Darwin. Okay? I'll let you make of that what you will. All right? But anyway, and you execute it. You avoid the kid. All right? That's the execution. That's the actual taking the action. So for prescriptive, we're really in decide. We're deciding what we're going to do, and then after that, I said acting is very important. All right, because we have to act on what we have gathered. Well, we don't have to. We should, in most cases. All right, so think about supply chain. All right, it's where you actually take action to address problems on the supply chain. Maybe you're addressing inefficiencies. Maybe you're addressing shortages. Maybe you're addressing abundances. You know, let's face it. You know, we don't always have shortages, right? Sometimes we may make too much. What do? We do prescriptive analytics. All right, let's talk about enterprise data warehouses. So I have up here a very simple definition, and I think it's actually a little bit too simple, hence the surprised emoji here. But it's basically just going to be a central repository that any employee and any person associated with a company can access and do analytics on. Okay, and the purpose of this is to remove a lot of informational silos. Okay, so we've talked about information silos in here, right? Okay, so information silos are whenever you have certain functional units that have access to information that's not available to the entire organization. So I think I used the example last time we talked about it. You got an accounting department. They know what the company's spending, but your sales department doesn't have a clue. Is that bad? Probably. Why might sales need to know what we're spending? Okay, is that an important thing in pricing? It's not the only thing in pricing. But in general, you want to avoid pricing things less than their cost. I think that's pretty fair to say. Why do we want to price things less than cost? Or wait. Why do we want to not price things less than cost? Okay, exactly. So, you know, when you're thinking about being profitable, okay, you're taking off your expenses. It's a simple definition, but you get the idea. Okay, so another important characteristic of enterprise data warehouses is that they can't be edited from the data warehouse itself. Now, that's not to say that the source material cannot be edited. Okay, so the idea is that it's immutable because it's organization-wide. However, you have various data owners for the different databases that it's comprised of, and those are, of course, going to be volatile. The enterprise data warehouse itself, however, is non-volatile. Does that make sense? So this is basically read-only. All right, so think back to yesterday. 4, 2, or 1. Okay? So, you know, you'd certainly want to consider the permissions. All right, I think it's actually 4, by the way. I think 4 is read. I think that 2 is write. I think that 1 is execute. All right, so this would be like saying chmod 444. Is that fair to say? I'm pretty sure it's 4. Enterprise data warehouse. All right, so you're going to have various subjects. All right, the subjects are going to be where you would go and you would really say, you know, what this is about. Think about the table name. Is that the subject? Probably. Think about the database name. Depending on how the EDW is really set up, you may use table names or you may use the name of the database that it's coming from. But the idea is that you're going to have organized columns and rows. All right, I think that's pretty self-explanatory. If you wanted to, you could certainly use online analytical processing. We're going to talk about that in a little bit. But the important thing is that this is integrated across all of the systems that the company is using. So for instance, Fort Lewis College, what systems do we use? Okay, we got Canvas stuff, certainly. What else? You got Web Opus, a banner. What else? Come on, you guys work in IT. What systems do you support? Office 365, that's probably a system. What else? talk about is necessary. What about what the accounts receivables are using? Like, what do you guys pay your bills on? Okay, so it's usually a third-party system, right? I don't know what it is here. I've never paid a bill here. Look at me, the delinquent. All right. That's a joke, by the way. Anyway, so integrated with all the systems. All right, time variant. We have time and day variables. All right, that's vital for enterprise data warehouses. We want it to be multidimensional. Okay, we want it to include everything it needs to. All right. Here is one example of what it may look like. So again, like I was saying, you have multiple data sources. All your different systems are all feeding into the enterprise data warehouse. All right. So then basically you're putting it into the database management system, and then this whole thing is the data warehouse. That's all this is saying. Okay. Don't overthink this. And then of course, when you have it inside of a single enterprise data warehouse, obviously you can do queries on it. All right. So some different issues to kind of work through with the enterprise data warehouse. All right, you may have to perform transformation on the stuff inside the data warehouse. Now, why maybe want to transform variables? Just in a general sense, not in a data sense. About a variable. Why might I want to transform it? Okay, are all variables in the same units? Okay, some stuff may be expressed in United States dollar. Some stuff may be expressed in Canadian dollar. Okay, is that confusing? Some stuff may be expressed in millions of dollars. Some stuff may be expressed in literal dollar amount. So you could transform it. All right, technically speaking, you're not changing the values. You're just changing how they are presented. So think about changing units. You all taking chemistry? Okay, so think about stoichiometry. All right, what are you doing in stoichiometry? Okay, so part of it is unit conversion, right? Same idea here. You're transforming the data. You're not changing it. You're changing how it's presented. All right, data cleaning. I don't really like this term, but basically, you're just going through and addressing possible issues with the data. So some possible issues. You could have data that's formatted incorrectly. You could have data that is missing. Okay? You could have data that is inaccurate in a systematic way. Okay? So you would address all that in data cleaning. Now, if data is inaccurate in a random way, what can we do about it? Nothing. Okay? So keep that in mind. You just got to throw it out. How to propagate updates. Are we going to do this synchronously? Are we going to do it asynchronously? And what that's really saying is, are we going to update this in real time? So if I have a TPS system, okay, it's feeding into my enterprise data warehouse. Am I going to update this for any transaction? Okay, so every time there's a transaction, am I going to immediately send it to the EDW, or am I going to wait 15 minutes and do them in bulk? Which way is more efficient? Yeah, doing it in bulk. Chances are good 15 minutes is not going to change the analysis very much, right? Probably not. Not to say that you would never want to have it done synchronously. Just know that it's going to be a lot more costly. All right, you got to think about what data to collect, what data to summarize. How are you going to do it? All right, so the same thing there. Okay, so here's an example of what a schema may look like in an EDW. Okay, so you got your item table, your store table, your customer table, your date table, and your sales table. This is one example. Is this the only example? Absolutely not. Okay, that's a pretty simple example though, right? In fact, I think that the ERDs you all did are quite a bit more complex than this, right? But the idea is that this is going to be organization-wide. Sales are vital, okay? Store locations, that's important. Who our customers are. Why does that matter? Why do we care who our customers are? Okay, so if your customers are college students, all right? You guys like Taco Bell? Okay, who likes Taco Bell? I like Taco Bell. Yeah, you know, nothing wrong with Taco Bell. That may be something that you all would like. All right? What's something else you all like? How do you do, fellow kids? That's what I feel like up here. What's that? What's Zia's? Oh yeah, I know Zia's. I thought it was like some product. It's like a food. I got you. Yeah. Okay. A lot of different options. Okay, so we have a lot of data, and we want to analyze it, turns it into information. You apply the information to solve problems, it becomes knowledge. All right, so as a company, we have a lot of that going on. And we want to ensure that everything we're doing is formally recorded. Okay, so that becomes intellectual capital. Okay, so another term for intellectual capital is intellectual assets, or even intellectual property. All right, so you got two types of knowledge, explicit and tacit. Okay, and explicit knowledge, what you're doing is you're having knowledge that can be formally recorded. So if I say 2 plus 2 equals 4, that's a fact. You can't argue with that. All right? Base 10, this is a fact. 2 plus 2 equals 4. Okay? If I said I think this is a stupid equation, that's an opinion. That's a tacit thing. You can argue with that. Okay? No, personally, I don't think 2 plus 2 equals 4. I don't think that's stupid. But if I did, that'd be an opinion. Does that make sense? So knowledge management system is going to be a way to disseminate knowledge throughout an organization in a very efficient way. Because as we know, as we collect and gather and process knowledge, we need to be able to reference it back. All right? Ron, you work in IT, right? Do you remember every single thing about every single system? Probably refer back to a knowledge management system, don't you? Mm-hmm. And it's important to keep that updated, because as stuff changes, you don't want to have a bunch of old knowledge. All right, so here's the knowledge life cycle. Not going to go through the whole thing. It's kind of boring, and it's not the most useful thing anyway. You acquire knowledge, you create knowledge, you refine it, you disseminate it. All right? So that's what you're doing as an organization, constantly going through that cycle. Okay? Because if you don't disseminate it and you keep it internal, that doesn't really help anything, does it? Okay? So we're going to go through online analytical processing a little bit quickly. I'll be honest, my opinion is kind of pointless. Well, it's not pointless. It's just like with next generation firewall. It's a marketing term. Okay, this is not a technical term. Because all you're doing is you're processing data. All right, you happen to be using an online system. All right, so the key here is online fashion. So in my opinion, it's not like some groundbreaking thing like a lot of people present it as. Okay? Because imagine if I walked in here and I said, it is absolutely the best thing in the world that I can access data online. You'd think I'd lost my marbles, would you not? Okay? So again, just a marketing term. Look at the example from the book. Okay, they have a sales table. They're getting the columns from it. Is that stuff we haven't seen? Oh, we've seen that 1,000 times. So when you run this, all right, this is what the sales table looks like. Nothing new. A couple different functions that it has. By the way, you can do all these in SQL. Pivoting. Okay, so you think back to 223. You did a pivot table. All right, so you got your different dimensions there, and then you have the tabs. Okay, so you basically have your X's and you have your Y's. All right, and you're just plotting it out. Okay, so really straightforward. Okay, then you get into slicing. So in slicing, what you're doing is very similar to pivoting, only you're having a fixed value you're applying that to. So you may only be interested in the pivot results if the if some grouping variable is like 1, 4, or 9. I don't know why you would do that, but you could. Okay. You have roll up. Okay, so roll up is where you're basically starting at a very very specific level, and you're moving to a more general level. So think about the granularity of like a day versus a year. Okay, which one's more granular? Okay, obviously the day. So, you know, when you're thinking about what this looks like, you're starting at a specific level and you're generalizing. Okay, in contrast with drill down, you're starting at a general level and you're going more specific. All right, so if you had a database with year, month, day, maybe you're starting at year and you're drilling down to end up at day. All right, we can do all this with SQL. Here's an example using pivot. Okay, so all we're doing, just inside of select, selecting everything from tell it which table. Then we're going to use the pivot function. So we're going to pivot based on the sum of quantity. And we're going to say for color of either dark, pastel, or white. All right, so that's all we're doing here. And then we're just ordering by the item name. So the item name, in this context, is going to start from A and go to Z. Okay? And you can see that we're only getting the colors we're interested in. Okay, that's what the pivot function is. All right? So we're adding up because we use sum of how many of each of these we have. Does that make sense? Any questions about it? So again, in my opinion, this is kind of pointless. But you can have your own opinion. Okay, so what we're doing with roll-up is we're just taking basically a union of everything that we may end up using. And again, we're starting at the very specific level and just generalizing. So we're forming those unions, and that's how we go about it. Okay, so inside your group by, you're just going to use a roll-up of whatever you're wanting to use. Okay, so you kind of specify which groups those may be that you're interested in, but the idea is that you're just starting at a very specific level, and then you're adding in additional things. So it would probably make a lot more sense if the example were something time-related, right? So we could, of course, group by and then have time. All right? Let's talk about data mining. All right, you guys are taking a data mining class, right? What class you guys taking with Ivan? Okay, that's what I thought. Why'd no one raise their hand? Yeah, but in general, I think a lot of you are in Ivan's class right before this. So you guys are doing data mining in there, okay? And really what data mining is it's semi-autonomous pattern discovery. What that means is that you have to get it started, okay? You know, you can't really have it be completely autonomous, all right? That's just not how things work. Okay, so when you're going through the data mining process, you're telling it, I want you to run these analyses, and it'll run the analyses you specify. All right? So there's a lot of different methods and techniques to this. Okay, there's not one single data mining approach. All right? But in general, what we're going to have as a result of this, we're going to have usable models. Okay? So what models may we be interested in as a for-profit company? So in a general sense. Is it fair to say we may be interested in models that predict revenue? Is it fair to say we may be interested in models that predict profitability? That's what we're interested in. Okay, so some different prediction methods we may use. All right, so basically anything we're predicting, base it on historical data, data that we've already collected, that we already have. So again, if you're wanting to do a training model on training for the presence of fraudulent transactions, and let's say that we are someone who has access to the data, okay, we can see what makes a transaction fraudulent, what makes it more likely to be fraudulent, okay? What about credit scores? Can we predict those? To a really high degree of certainty, okay, if we have the appropriate data. So some different prediction methods we may use. Use classification, where we classify stuff, okay? Regression analysis, where we regress a dependent variable based upon the independent variables, which also, of course, can be referred to as explanatory. Okay, clustering. You guys done k-means clustering? Okay, so clustering is looking at where data points are. What are they close to? Okay, and it's doing that using algorithms, obviously, not visually. Okay, and then association. What is stuff related to? This is kind of getting close to cause and effect, but of course we can't really determine a cause from data mining. We can only surmise what may be a cause. Have to determine a cause by other things. Logic. Okay? What makes logical sense? If I say that diapers and beer are associated with each other and their sales, doesn't tell you why. Okay? Babies aren't drinking beer. All right? Hopefully not, at least. Okay? But they're associated with each other. So the theory behind it is that dads, when they go to the store, they get something for the baby, they want to get something for themselves. All right? I'm not here to say whether that's right or wrong. That's up to you to decide. But that's what we're talking about. I guess one common example is stuff like a decision tree. Okay, so you have your different decisions. Okay, these are going to be stuff that we could use as a grouping variable. Okay, so we have what degree someone has. Do they have no degree, a bachelor's degree, a master's, or some sort of doctorate degree? Okay, then we say what their income is. Okay, and this is going to tell us, you know, how likely that is. Okay, so the average for someone with no degree, according to this, is going to be around 50 to 100K. All right, so that's what we're doing with a decision tree. Let's go back to SQL though. So we have different SQL we can do inside, or different analytics we can do inside of SQL. So we can do a good bit. Okay, we have all the mathematical operators. We got addition, got subtraction, got multiplication, division, got the mod operator, then we have and, or, and exclusive or. Okay, so a lot of stuff we can do, right? Okay, we also have our aggregate functions. We can take the average, the min, the max, the sum, the count. These are all pretty useful stuff, right? But does that encompass everything we may need to do in analytics? Not even close. Let's talk about how we integrate with R. Okay, this is the last thing we're going to cover today. Next class, we're going to pick up with doing examples. So make sure you attend next class. Make sure you attend every class, but especially next class. Okay, so a couple different options we have to integrate with PostgreSQL and R. Okay, inside of R, you can use the ODBC package. And by the way, I linked the help file from RStudio for this. So if you're wanting to do this, check it out. Okay, so there are 6 components of OBDC that you have to specify. All right, so the first is the driver. Okay, so the driver is basically saying which database version are you using and which driver you're using to support that. So there's a whole driver section that you would read through to find that information out. All right, the server, What's the address of the server? How do we get to it? Okay, pretty self-explanatory. The database, what is the name of the specific schema that you're in? Okay, so when you create a schema, you have different tables within inside of that schema, right? So you're basically just identifying what the schema's name is. All right, then you have the user ID. It's the username of your account. Then you have your password of the account. And finally, you have the port. Now, by default, PostgreSQL uses port 5432. Okay, so that's why it says the port should be that. I'm gonna be honest, I copied and pasted this from the help page. Okay, I'm not gonna lie. Okay, so here's an example of integrating this with R. Okay, so what you would do is you would have whatever you're calling your connection, and you define it using DVI and the DV connect. So you're going to use the OBDC, or ODBC, using that library, and you're specifying all the information. Okay, so you got your driver's name, service address, your database's name, so it's your schema's name, user account, password, and port. Is that a pain? It's a pain. Well, luckily for you all, there's an easier way to do things. All right. So there's also our Postgres, or Postgre, however you say it. I don't really care. All right. So this is a package. It's going to be a lot easier. It's going to simplify a lot of this. You're not going to have to mess around with drivers because it includes it inside of the package. You're not having to mess around with any of that. All right. You guys like doing stuff the easy way or the hard way? Who likes doing stuff the hard way? Who likes the easy way? This is the easy way, okay? Literally, all you're specifying is your host, your port, your user, and your password. And that's pretty simple, right? Because you're probably using localhost, so that's going to be 127.0.0.1, right? Okay, your port, you probably left that as default. You could have changed it if you wanted, but it's probably going to be 5432. Your username is going to be your username that you used for the creation of it, and your password is going to be your password. This is all you got to do. All right. So up here is the example if you wanted to connect to the default one. You're probably not going to do this reasonably, right? Is it fair to say you're probably more likely going to have a specific schema you wanted to connect to? This is probably going to be what you end up doing. But if you want to keep things simple, put everything in the default schema, this is literally all you had to do. A single line. Is that not the coolest thing you've seen today? Okay, who's seen something cooler than this? I think this is probably the coolest thing you've seen today. Simple. Okay, very easy. All right, just to wrap things up, we talked about data analytics today, talked about the different types of it, talked about data warehousing, what it is, why it's done, how it's done. Talked about online analytical processing. Didn't go too much into it because, again, it's basically analytical processing done online. Not very difficult. Talked about data mining. And finally, talked about what we can do in SQL Analytics. Questions about anything? All right, make sure you don't skip class Tuesday. I'll see you all then. Actually, I'll see you all tomorrow, won't I? All right. Either way, have a good one, guys. See you eventually.